We have also discussed about data mining, unsupervised learning. When I say unsupervised learning, the output variable is not known or not given in the historical data. So the labels, output variable labels are not known to us. As part of unsupervised learning, we have discussed about clustering. Clustering is grouping related records together. So grouping similar records together, and at the same time clustering has another objective of placing dissimilar records as far apart as possible. That's your clustering. And within clustering you have non-hierarchical clustering and hierarchical clustering. Hierarchical clustering and non-hierarchical. As part of hierarchical clustering, we upfront do not determine on the number of clusters. So what we do is we get started by assuming that each record is a cluster. Then we calculate the distance between all pairs of records. How do you calculate? Using Euclidean distance or Manhattan distance or Mahalanobis distance. Yeah, you use any of these to calculate the distance between the pairs of records. And then we are going to group what? We are going to group those records which have the least distance. So group the records with least distance. Once you have groups and records in place, we need to calculate the distance between groups and records. Calculate distance between records and groups, or between different groups. Now whenever you want to calculate the distance between different records which are numerical, then all these three work very well. But what if you want to calculate the distance? Calculate the distance if you have, say, discrete or categorical data which is binary in nature. Then you need to convert that binary data, for example, male female, male equal to 1, female equal to 0, pass fail, defective not defective, default on the loan, will not default on the loan. If you have this kind of a binary data, then you actually convert that into binary table and then calculate the distance. For this you have three measures once again. One is binary Euclidean distance, and when it comes to binary Euclidean distance, this is called as measure of dissimilarity, right? And then we have another measure called as it is simple matching coefficient. This is a measure of similarity. And then we have another measure which is called as Jacquard's coefficient. And this Jacquard's coefficient assumes that two people not doing something doesn't determine the similarity. Two people doing something would determine the similarity. Right? That's the logic. And then this is fine. What if you have data? What if you have discrete data which is not binary, which has more than two categories? Then we apply a simple rule wherein if two records have similar values, then distance equal to 0. If two records have dissimilar values, then the distance is equal to 1. Simple. This is what we do if discrete data is greater than two categories. And if you have mixture of discrete and continuous data, or discrete and numerical and non-numerical data rather, if you have that kind of a combination, then you go with Grover's distance measure. All right. This is all when you want to calculate the distance between, say, a record and a group, or two records, etc. Now, especially when you have two groups, or if you want to calculate the distance between a group and a record, we employ various methods. That is, you can go with something called as single linkage. Within single linkage, we look at the nearest neighbor. Nearest neighbor measure. So you look at the two entries within two different groups which are very close to each other and try to find out the distance. Or if it's between a record and a group, then from that record you try to calculate the distance to the nearest value in the cluster. This is how it appears. So to quickly explain you all. If you have two groups and say you have multiple data points, when it comes to single linkage, you calculate the distance between the nearest values, nearest neighbor. You'll not go for a value which is very far away in both these clusters and then calculate the distance, right? And there is another linkage which is called as complete linkage. Here you look at the farthest neighbor. So you're looking at the dissimilarity rather, right? You pick the farthest data point here and the farthest data point in the other cluster, and you probably try to calculate the distance in that way. That's going to give you the complete linkage value. Then you have average linkage. You take the average of all these data points in cluster A, you take the average of all the data points in cluster B, and then calculate the distance between those averages. That's called as average linkage. And then we have centroid linkage. Calculate the centroid of both the clusters and then calculate the distance. Finally, we are not done yet. These are all the different ways of calculating the distance, etc. Finally, we look at the dendrogram. So review the dendrogram to determine the most optimum number of clusters. And then you devise the strategies on those clusters and work on that. How is it different from hierarchical clustering? As part of this, we have discussed about k-means clustering. Here we upfront determine the number of clusters. How do we determine? The basic thumb rule to determine the number of clusters is square root of number of data points by 2, or even better is scree plot or elbow curve. Right? Scree plot or elbow curve. That's even better. That is how you determine the number of clusters when it comes to k-means. Then we have also discussed about dimension reduction. When it comes to dimension reduction, okay, even before that, when it comes to clustering, non-hierarchical clustering, we basically look into within sum of square values. Within sum of square value, less the better, because less implies more closeness, which implies more similarity. That's within sum of square. Then what do we mean by between sum of square? Between different clusters, there has to be more distance. So more the better. What does more mean? More dissimilarity. Right? The better. So you'll be in a better position to differentiate between these two. And these are the two key values using which you can, determine on whether you have got a good cluster or not. But when it comes to clustering exercises, the success is determined on appropriate labeling of different clusters.